Hi, my name is Leo Francis A. URK24 CO 2005. This is Object Oriented Programming Laboratory 23 2002, experiment number 8. So, in this experiment, I have totally two programs. The first the first program is about a matrix thread program, which performs addition, subtraction, and multiplication of two matrix using separate threads for each matrix. And the another program is a banking thread program system which simulates synchronized deposits and withdrawal operations. So we'll go from the first one. So the matrix set program. So the overview of this program is it takes two matrices as input from the user and it performs three operations: addition, subtraction, matrix addition, the matrix subtraction, and the matrix multiplication. So each of these operations it runs on its own separated threads. So over here, as you can see, it has the class called matrix operation, which represent one matrix operation. So this matrix operation class implements the runnable interface, which allows it to be used by a thread. So for each operation, addition, subtraction, multiplication, an object of this class is created, as you can see over here. So these object stores two matrices and the operation name. And when the thread starts, so as you can see over here, we have created three objects. So as the thread starts, the run method checks with the operation to perform and it executes the respective logic, whether it's addition or subtraction or multiplication. So in the main program, three objects have been created, one for addition, one for subtraction, and one for multiplication. Each of these objects is passed to a separate thread. So as you can see over here, each of this is passed through a separate thread. So we have three threads running at the same time. So each performing a different matrix operation. This concept of thread is used to utilize the CPU power more efficiently all over the world, in all over the programming language world. The concept of using thread is to make the utilization of the CPU or to make the utilization of the power efficiently. So here all the three threads are started one after another. So a minute there's only a minute difference between the execution of each operation. So once I run the code, you can see that. So as you can see, it asks the user the number of rows. I'm giving 2 and columns 2. So it asks me, so I'm giving 10, 20, 30, 40. So as you can see, the elements of B is 50, 60, 70, and 80. So when I give enter right now, you can see that the operations addition, subtraction, multiplication, it will be happening within seconds. As you can see over here, the like if this program is not run by the thread, first the addition will get run, and then after that the subtraction will get placed, and after that the multiplication. So it uses the CPU power. It takes more time to run the program. So in this program, what we have done is we have created three separate threads: one for addition, one for subtraction, and one for multiplication. Doing that, so it performs so fast, like only a minute seconds or milliseconds or some so minute seconds only. The that's why we also call that as a parallel execution. So that's the first program over here. And the second program is it's a banking thread system or a banking thread program. So it creates like it simulates a simple banking account where multiple threads try to deposit and withdraw money at the same time. So instead of Instead of doing deposit first, withdrawing first, and again deposit first, we use multiple threads to do everything at the same time, which again I said the concept of using thread is to make the CPU utilization more efficient. So the main purpose of this program is to demonstrate the synchronization in Java. So it contains a balance variable. As you can see, this bank account class contains a balance variable and two main important functions. One is deposit method and another is withdraw method. Both of these methods are marked as synchronized. As you can see over here, both of the methods are marked as synchronized. That means that only one thread can access the balance at a time. So if two functions tries to access the balance at the same time, uh, they might get to wait forever. Then the utilization will be waste. So that's why we use synchronization in this program. And why the synchronization is very important in this program is if multiple threads or if as I said, if two functions or multiple threads uh, try to use the variable or try to update the balance variable at the same time, it can lead to incomplete or incorrect results. So, for example, two threads may withdraw money thinking that there is enough balance to withdraw, but but the balance is not enough. So that can lead to the program failure over here. So by using synchronization, what we do is that only one thread can deposit or withdraw at any given moment. So in one time, two withdrawals, two deposits can't be done because synchronization is used in this program, and we ensure like every balance the update of the balance variable is very accurate. And over here you can see that there are three threads. One is for depositing, and there are two threads which is used to withdraw. Each thread perform its operation three times. So the threads also sleep briefly in. So as you can see over here, the as you can see, the thread also sleeps briefly in between operations. So we can observe what is happening between the operations, how the operations are taking place over here. So while running this code, you can see over here. So as you can see, uh, the deposit withdrawal it happens simultaneously, but since we use synchronization, after depositing only withdrawing will happen, after withdrawing only deposit. So even though we use synchronization, it will happen at fast. So the reason why we use the sleep function is, as you can see, a little delay is happening because it helps the user or the to the programmer to view what is happening between the programs and to know what is happening. So this is the main advantage of threads in this program. So this is experiment number 8. Thank you.